4.2, we are now solving systems in 3 variables. So you could see something that looks like this. 2y subtract y plus 3z equals 13. X plus y minus z equals negative 2. 3x plus 2y plus 2z equals 13. Now, this is, you don't see any exponents on the variables, you don't see any radicals, you don't see any absolute values. X, y, and z are not in the denominator. So this is still straight, like a line. But there's 3 variables, so it's not a line. This is actually a plane. And a plane is like this paper is a plane. It's an example of a plane, and it would go infinitely in all directions, and that would be a plane. And if I turn it slightly, for example, if I bring this paper in and I turn it like this, that is another plane. And if I put it straight perpendicular with it, you can see my spiral notebook, that is another plane. And those 2 planes meet in this line right here where they have infinite points in common. Now if I add a 3rd plane to that, let's say my hand makes a 3rd plane. Now imagine that my hand can go through my spiral notebook and it's going in all directions. Then eventually right here, the plane, the spiral notebook, the paper on the table, and my hand, those 3 planes all meet, but they only meet in this one point right there where they all cross. And so once again, you're finding the x, y, and the z that they all have in common. And we're going to do that. Let's go ahead and write the steps like we did before. First of all, we're going to eliminate the same, and that's key. You have to make sure you do the same variable. I see people do different variables all the time, and it doesn't get you anywhere. In 2 different pairs of those planes, okay? Then we're going to solve that smaller system. That will make us have 2 variables in 2 equations. So we'll solve that smaller system that you just created. And you'll see what I mean in just a second. And then you'll have 2 of your variables, and so you have to put those 2 variables in one of your originals. In one of your original equations to get your 3rd variable. Okay, so let's go ahead and try that. So looking at our 3 equations, you can pick any variable, x, y, or z, that looks easy to eliminate. And z looks kind of nice because you have positive and negative, so you wouldn't have to worry about the sign. Oh, but look, I have positive and negative on y's too. And it might be even easier because it doesn't have coefficients. But we have to do it twice. But I'm thinking this clearly looks like the easiest y to eliminate. So let's begin by adding those 2 equations right there. And I'll just write my answer right here. So adding these 2 equations, I get 2x plus 1x is 3x. Negative y plus positive y is 0, so they're gone. And then I have positive 3x minus z, so I get positive 2z. And 13 and negative 2 is 11. Okay, now here's the key. You just made an equation with x and z. So now you have to make another equation with x and z. So come up here and you can either use the top and the middle or the middle and the bottom. It just has to be a different pair. But you have to eliminate y again. And so I'm looking at those thinking these 2 look the best because this one's negative and this one's positive. So let's use the top and the bottom equation. And in order for y to cancel, I can't add those as is. We were able to add those and y canceled automatically. But if I add those, y will not cancel. So to make it cancel, I'm going to multiply this top equation by 2. So I'm going to multiply that by 2, and I'm going to write it right here. So I now have 4x minus 2y plus 6z equals 26. Then I'm not going to change anything. I'm just going to copy the bottom one. Remember, we were doing the top and the bottom. So I'm just going to copy the bottom one down without changing anything. Sometimes you may have to multiply both equations to make something cancel, but we only had to do one. So that's that equation right there. Alright, now adding those up, look what happens. 4x plus 3x is 7x, and my y's cancel. That was our objective. 6 plus 2, I now have 8z, and 26 plus 13, 39. Okay, now look what you've created. You have this line and this line. So now you have a system just like you learned how to solve in the last section. And you can solve it. You have 2 variables and 2 equations. And you can use elimination or substitution, whatever you want. I wanted to use elimination just to remind you of it, but I can see that 11 divided by 2 or 3 is a fraction, as well as 39 divided by 8 or 7. So if I isolate a variable, I'm going to make fractions. So let's use elimination again. And it's kind of tricky to make 3 and 7 the same, but I can make z cancel pretty easy. Do you all see it? Let's go ahead and multiply this equation by negative 4. And so I'm going to go ahead and just write that right here. So if I multiply by negative 4, I have negative 12x minus 8z equals negative 44. And then I'll copy this equation down without changing anything, because we made it so that our z would cancel. So now we're going to add those 2 equations together. And z cancels just like we hoped it would. And I have negative 5x. Ugh, that's kind of sloppy. My bad. Negative 5x equals negative 5. So dividing by negative 5, we get x equals 1. Now we stick with our smaller system and we plug that back in to get z. So let's just plug it in. You can plug it in here or here or here or here, because those are equivalent and those are equivalent. So let's just use this one. Well, let's use our smallest numbers. Let's plug it in our first one. So if I plug it in right there, I have 3 times, and instead of x, I put 1. 3 times 1 plus 2 times z equals 11. So I now have, this is 3, and I'm going to subtract 3 from both sides. So I have 8, and then I'm going to divide by 2, so I get z equals 4. And I will admit, these are the longest problems of the whole semester. They're going to use some space. Don't be afraid to use your paper. Use some space. Now, you've got z and you've got x, but you still need y. So this is what we've done. We eliminated the same variable. We eliminated y twice. And then we solved our smaller system. We got z and we got x. So now step number 3 says we put those back in one of the originals and get the third variable. So I think our middle equation looks the easiest. So I'm going to plug it into this right over here. So instead of x, I know x equals 1. So I'm going to put a 1 there. And then I don't know y, so I'll leave y as y. But z is 4. And we know that that equals negative 2. So combining like terms, I just add my consonants on this side. And then I'll add 3 to both sides. And so we get y equals 1. And then their answer is just in alphabetical order. X, y, z. And it's a 3 variable point. And that is the solution to that system. That's where all three of these planes meet. All right, done. Now, you could run into some scenarios if your variables cancel and you have a false statement. Remember that there's no solution. That tells you that all three planes never meet in one point, one common point. Or you could get your variables could cancel and you could have a true statement. And if that's true, you need to write it like I'll show you on my notes. And if you have a problem, you can text me. You need to write it like this: X, Y, and Z. That's kind of light. I'll do it right here. It would look like this: X, Y, and Z are such that, and then just write one of your equations. So if it were this one, I would write any of those three equations. And all of that would be in squiggly brackets. And that's what you do if your variable cancels and it's a true statement, because that tells you that at least two of them intersect in a line, and so that means there would be infinite solutions. All right, good luck, you guys.